I'm Charles. I'm taking history because I'm gathering transfer credits at Schoolcraft College. I'm taking this class for that reason. And a fun fact about me is I used to play football at Trine University. Over the semester, I've researched and studied Johannes Kepler, his laws of planetary motion, and his astronomical findings. Johannes Kepler was a German philosopher who discovered the three laws of planetary motion. He was also a very important mathematician. His intelligence earned him a scholarship to the University of Tübingen, where he studied Lutheran ministry. Kepler became a student and teacher, teaching mathematics at Seminary School of Graz. Mysterium Cosmographicum was a book written by Johannes Kepler. This book is based on astronomy and was published at the University of Tübingen in 1597. Kepler introduced the distance relationship between the six planets at the time could be understood using the terms of the five Platonic solids. Kepler was a strong supporter of the Copernican heliocentric view of the then known universe, which was the model that the Earth and planets and stars revolve around the sun. He was also a supporter of the Copernican cosmological doctrine. In an article, Johannes Kepler, His Place in Astronomy, states that Kepler had a real deep belief in his thoughts on the universe. Kepler succeeded to establish the Copernican cosmological doctrine on plausible scientific realistic grounds, but also within the framework of his religious and philosophical thinking. Kepler's creative mind succeeded to formulate explicitly the physical laws named after him and open new pathways in all subjects he penetrated. Kepler kept his scientific beliefs in line with his religious and philosophical agendas and theories to make his scientific theories make more sense and abstract to him. This led to other astronomers and mathematicians to spread and complement his work. Kepler put 10 long years of the investigation of Mars into a book called the Astronomia Nova. This book provided insight on the movement of planets. The book included the first mention of planets' elliptical paths and change of their movement. This book formulated Kepler's first two laws of planetary motion. The first law states that each planet moves on an elliptical path with the sun at the focus. This law was a theory that supported heliocentrism, with the sun being at the center focus and the planets revolving around the sun. The second law states that a line connecting any planet to the sun sweeps out an area at a constant rate. This law has two different forms, which are paraphrased follows. 1. The velocity of a planet varies inversely as the distance from the sun. And 2. The velocity of a planet varies in such a way that a line joining the planet to the sun sweeps out equal areas at equal times. This law was the first talk of elliptical orbit and gravitational pull, as it implies that velocity changes with distance to the sun. After Kepler gave thought to the second law of planetary motion, he investigated the Earth's orbit. He found a difference in speed with different distances from the sun. Another example to support this is a book called Johannes Kepler and the New Astronomy. It states, Kepler was able to investigate the Earth's orbit and he found that Earth shared the physically non-uniform motion of other planets. It too speeded up when it approached the sun and slowed down as it receded. In 1618, Kepler came up with his third and final law of planetary motion. The squares of the sidereal periods of revolution of the planets are directly proportional to the cubes of their mean distances from the sun. This law stated that the square of a planet's orbital period is proportional to the cube of the semi-major axis of its orbit, stating that if you calculate the year of each planet and divide it by the cube distance to the sun, you get the same number. This means that every time a planet revolves around the sun, it is approximately 1 year and will have another cycle to go through. He found this within elliptical orbit, not the seasons of the weather. Kepler was also very aware of experimental errors. He used experimental errors to guide him to the right conclusion. In a summary of the writing on Kepler's awareness of the problems of experimental error, we can see that he's very aware of errors and stands up to them. It states, to use Kepler's own words, that errors show us the way to truth. With a survey of Kepler's revolutionary contribution to optics, the paper demonstrates that Kepler's awareness of the problem of experimental errors extended beyond discrepancies between calculations and observations to types of error which pertain to observations and instruments. Kepler showed he had the right mind to expand and grow the roots of astronomy. He used the right philosophical knowledge to infer his truths and expand his knowledge within astronomy. Johannes Kepler started the pinnacle point in astronomy with his findings. He studied astronomy and figured out the three laws that planets in our solar system follow. These laws are called the three laws of planetary motion. He also studied the orbits of planets and found other theories there. He studied mathematics and astronomy, mixed it with his philosophical thinking to find pinnacle and rational points in the first observations of astronomy.